Hello everyone, welcome to our second lecture on normalization in DPMS. In the first lecture we have discussed about the first normal form and the second normal form and how we can decompose a relation into first normal form and then how to decompose a table depending on the fully functional dependency to the second normal form. Now we are going to discuss about the third normal form and the BCNF or Boy's Code normal form. Now, in 2NF, we have learned that if any non-prime attribute is partially functionally dependent on the candidate key, then we need to decompose it. Now, from there, we are going to discuss the third normal form. Now, third normal form deals with transitive functional dependencies. What is a transitive functional dependency? Suppose in a relation R, there are three attributes x, y, and z. Then if x determines y and y determines z, then we can use the transitive rule of inference to write x determines z. Now this kind of functional dependencies are called transitive functional dependency. In simple word, if any attribute or a set of attributes z is functionally dependent on a set of attribute x, but through any other attribute, then it is a transitive functional dependency. Now, from here, the definition of third normal form comes. It says that a relation R is said to be in 3NF if it is in 2NF. So, first of all, it should be in 2NF, and every non-prime attribute means every attribute which is not a part of a candidate key are non-transitively dependent on the candidate key. Every non-prime attribute, if there is a transitive functional dependency on the candidate key, then we can say that the relation is not in 3NF, and if there is no such functional dependency, then we are going to say that it is in 3NF. Now let us take some examples and see how we can use the concept of how we can use the definition of 3NF to determine the relation is in 3NF or not. So in this example, we have already discussed this in case of 2NF. We have seen that the actual relation R was not in 2NF because x determines z, making the wx determines yz a partial functional dependency. That is why we have decomposed the R into two smaller relations. In R2, we have x and z attribute. So, the functional dependency present in R1 is wx determines y, and the functional dependency present in R2 is x determines z, using the functional dependency given in the actual relation. So, here you can see that the non-prime attribute, now you can see that here the candidate key is wx, so the prime attribute will be w and x. Similarly, here the candidate key is x, so prime attribute is also x. So non-prime attribute here is y and here non-prime attribute is z. Here you can see that the functional dependency says that wx determines y. So the non-prime attribute y is non-transitively dependent on the candidate key wx. So here we can say that the R1 is in 3NF. Obviously we have proved that it is in 2NF in previous case. So the two condition, the relation need to be in 2NF, which is already proved, and the functional dependency present here should be a non-transitive type for non-prime attribute. So we have proved that it is also R1 is in 3NF. Similarly, the R2, here the non-prime attribute z is non-transitively dependent on the candidate key x. So we can say that R2 is in 3NF. So there is no need to decompose R1 or R2 to make it a 3NF. It is already in 3NF. Now in the next example, now come to the second example. Here we have discussed in 2NF that R, A, B, C, D, E are the relation with the attribute A, B, C, D, and E with the functional dependency A, B determines C and D determines E. Candidate key was A, B, D. So the relation was not in 2NF, so we have decomposed the relation in three relations so that all the three is in 2NF. Now let us discuss, is it in 1NF or is it in 3NF or not. We have ensured that it is in 2NF, so let us take, is there any transitive functional dependency or not. Now in R1 the attribute is A, B and D, and from the base functional dependency table we can see that there is no functional dependency between A, B and D, right? So we need not to worry about the R1. Now in case of R2, from the base functional dependency table we can say that AB determines C, and in case of R3 we can say that D determines E. So here AB is the candidate key. So A and B are the two prime attribute, where the C is a non-prime attribute, and the non-prime attribute is directly dependent on the candidate key AB. Similarly, in R3, E is the non-prime attribute which is directly dependent on the candidate key D. So R2 is in 3NF and R3 is in 3NF. So we can say that R1 is in 3NF. Similarly, R2 is in 3NF and R3 is in 3NF. So no need for decomposition to make it in 3NF. Now in the third example, we have discussed that R is a relation with 5 attributes A, B, C, D and E, where the functional dependency given by AB determines C, C determines D and D determines E, where the candidate key was AB and the prime attribute obviously will be A and B, and the non-prime attribute will be C, D and right. So from the functional, and we have proved that it was in 2NF. Now here the functional dependency A determines B, and from this we can say that AB determines D and AB determines E using the transitive rule. As the non-prime attribute D and E are transitively dependent on AB, that is through C they are through C D is dependent on AB, and through D E is dependent on AB. So there is a transitive functional dependency. So this is a transitive functional dependency. So this functional dependency is transitive functional dependency. Obviously this is also transitive functional dependency. So the non-prime attribute D and E are transitively functionally dependent on the candidate key A and B. So though the relation R is in 2NF, the relation R is not in 3NF, and as it is not in 3NF, so we need to decompose a relation into its 3NF form, third normal form. So how we can decompose it? First of all, take the candidate key in a relation. So the first relation will be with A and B and any other attribute which is directly dependent on the candidate key. So the C is the attribute which is directly dependent on the candidate key. Now after that, consider the functional dependency for which the 3NF is violated. So this is the functional dependency for which the 3NF is violated. So consider that one and create a relation with those attributes present in that functional dependency. So the second relation will be on C and D. Similarly, the third relation will be on D and E. So finally, we can say that my decomposed table R1, R2 and R3 is in 3NF. Now the this is how we are going to analyze our relation is in 3NF or not. Now, it may be sometimes very confusing to determine is there any transitive functional dependency or not. Similarly, to determine 3NF directly, we need to determine it is in 2NF or not. So, overcome this problem, the alternative definition or the general definition of 3NF is given, and it is like a relation R with a set of functional dependency F is said to be in 3NF for every functional dependency X determines Y in F, where X is a subset of attribute in R and Y is any single attribute of R. So X will be a subset of attribute from R and Y should be a single attribute of R. At least one of the following conditions satisfied. The first condition is X determines Y is a trivial functional dependency. What is a trivial functional dependency? FD X determines Y in a relation R is said to be trivial if Y is a subset of X. As you know that X can be a subset of attribute. So suppose X is basically A and B. So if we write and Y is B, so if we write X determines Y, here Y, that is B, is a subset of X. That is why this functional dependency will be called a trivial functional dependency. So the first condition says X determines Y is trivial, that is Y is a subset of X. The second condition is X will be a super key. And the third one is Y is a prime attribute. Remember, if for each and every functional dependency, if any one of the conditions satisfy, we are going to say that the relation R is in 3NF. So from this taking these three conditions, we are going to determine our relation is in 3NF or not. And what is the advantage of this one? We need to analyze for 2NF. We can directly analyze these three conditions for checking the relation is 3NF is in 3NF or not. And from this definition also we are going to get the definition of the BCNF. So let us take how to analyze a relation is in 3NF or not using this definition. So let us take this is the example we have already discussed in case of 2NF. We have determined that ABD, ADE and ACD are the three candidate keys. So the prime attribute will be AB, A, B, C, D and E. As all the five attributes are prime attributes, so the non-prime attribute will be null. So there will be nothing in non-prime attribute. So it is in 2NF, which we have already proved. Now, the functional dependencies over R is AB determines C, CD determines E, and DE determines B. So you can see that there are no trivial functional dependency. So let us take the second condition. X is a super key. Here X means the set of attribute present in the left hand side. So this is my X, this is my X and this is my X. And this is my Y, this is my Y, this is my Y. Remember, we need to satisfy any one of the condition for each and every functional dependency present in the relation. So is for the first functional dependency, is AB a super key? Obviously not. For the second functional dependency, is CD a super key? CD is not a super key. Similarly, DE, is it a super key? No, it is not a super key. Now let us take the third condition. So first two condition does not satisfy for any of the three functional dependencies present in the relation. So what is the third condition say? It says that Y is a prime attribute. Is C is a, yes, Y means C is a prime attribute. Obviously C is a prime attribute. Is E is a prime, so this functional dependencies satisfy my condition, one of the condition of 3NF. Is E is a prime attribute? Yes, E is a prime attribute. So the second functional dependency also satisfy my condition of 3NF. What about the third one? Is B is a prime attribute? Yes, B is a prime attribute. So all the three functional dependencies satisfy one of the condition of 3NF. So as this is true, we can say that the relation R in having A, B, C, D and A attribute is in 3NF. So R is in 3NF. So no more further decomposition is required. So in our fifth example, R is a relation with 5 attributes A, B, C, D and E, where the functional dependencies are AB determines CDE and E determines B. By analyzing the functional dependency, we can see that AB determines CDE, also obviously AB determines AB, so AB will be a candidate key. Similarly, as E determines B, we can replace B with E and that will determine all other attributes in the relation. So AE also can be a candidate key. Now the prime attribute here is A, B and E and the non-prime attributes are C and D. Here the functional dependency is given by AB determines CDE. Now here X is AB, here X is E. Now y in the second case Y is B is my Y as per the general definition of the third normal form. Now CDE cannot be my Y because Y should be a single attribute. So using the decomposition rule, we can write AB determines C. So this is my X, this is my Y. AB determines D. So this is my X, this is my Y. And AB determines E. So this is my X, this is my Y. So we need to analyze all the four functional dependencies satisfying any one of the condition of general definition of 3NF. AB determines C. Is AB a super key? Yes, AB is a super key, right? Because as it is a candidate key, so AB is a super key. So as AB is a super key, all the three conditions satisfy one of the condition of the 3NF. So we need not to further analyze all the three of this set of functional dependency because AB is a super key. Now in case of so we need to analyze the second functional dependency. E determines B. Is it trivial? No, it is not trivial. Is E is a super key? No, E is not a super key. Is B is a prime attribute? Obviously, B is a prime attribute as it satisfies the third condition that Y may be Y is a primary attribute. So we can say that the relation R having this functional dependency is in 3NF. Now from these two examples, you can clearly see that a relation with multiple candidate key can be in 3NF. Now the problem with that is that which candidate key will be my primary key. As it is dependent on the database administrator, there are three options in this case for database administrator to select one of the primary key. Here there are two options to be selected by the database administrator. So overcome the problem of multiple possibilities of primary key, a higher normal form has been proposed by EF Code, which is called the BCNF or Boyce Code normal form. Here, what is the definition of it? It is a stronger form of 3NF and it removes the third condition of general definition of 3NF. It says that a relation R with the set of FDs F is said to be in BCNF if for every fd x determines y in f, where x is a subset of attribute in R and y is any single attribute of R, at least one of the following conditions satisfied. What are the following conditions? If x determines y is a trivial, or X is a superkey. There is no scope of Y can be a prime attribute which is available in 3NF. So the third condition has been removed from the definition of BCNF. Now what is the improvement made by the BCNF? It ensures only one possible primary key in a relation. So let us take what is that. Now to analyze the BCNF, to analyze a functional dependency is in BCNF or not, we are going to use the examples which we have already discussed. Now example 4 is this example where we have proved that the base relation was not in 2NF, not in 3NF, so we have decomposed in 2NF and get three relations from it. Next, we are going to see the three relations we are getting is in BCNF or not. So here there is no functional dependency, so we need not to worry about it. Here the functional dependency is C determines D. So C is my X and D is my Y. So X is a super key. Yes, X is a super key. So R2 is in R2 satisfying the second condition of the BCNF. So R2 is in BCNF. Similarly, D determines E. Here, D determines E. Here, D is my X and E is my Y. So X is the super key. So it satisfies the second condition of the BCNF. So the R3 is in BCNF. So we can say that R1, R2 and R3 is in BCNF. Now let us check. The example 5, which is one we have already discussed, was in 3NF. This one was in 3NF. Now let us it is in BCNF or not. BCNF, it says that each and every functional dependency X, and this is my Y, this is my X, this is my Y, this is my X, this is my Y. Now is any one of the relation is any one of the functional dependency is trivial? No, it is not. So the first relation is AB is a super key. Obviously AB, that is X, is not a super key. So the first functional dependency does not support my condition of BCNF. So from here directly we can say that though the relation R is in 3NF, it is not in BCNF. So we need to decompose it into SBCNF form. So take the functional dependency for which it is not in BCNF and create a relation with the attribute present in that functional dependency. So I will get R1, AB and C. So here the functional dependency is AB determines C. So that is in this relation AB will be the super key. So R1 is in BCNF. Similarly, the second functional dependency CD determines E. X is not a super key. The CD, which is X, is not a super key. So we need to take this functional dependency and create a relation based on this functional dependency R2. So we will get C, D and E in this relation. So CD will be my super key. Similarly, for the third functional dependency DE determines B, we will get another relation R3 with the attribute D, E and B. The relation R, which is in 3NF, was not in BCNF. So here we are decomposed into three relations which are in BCNF. So you can see that as in the relation R, the actual relation R, as ABD, ACD and ADE are the candidate key. There are possibility of three primary keys, but when we have decomposed it into its BCNF form, each and every relation will have only one primary key. For relation 1, AB will be the primary key. For relation 2, CD will be the primary key. And for relation 3, DE will be my primary key. So BCNF ensure the possibility of a single primary key in a relation. Next, let us take the example 6, which is similar to our this example. We have proved that the relation R was in 3NF. Now, let us discuss what is it in 3 is it in BCNF or not. So the functional dependency available over here is AB determines CDE. Let us break that in decomposed form. AB determines C, AB determines D, AB determines, and E determines B. Here the super key here A, B is the X, C is my Y, D is my Y, E is my Y. Now here E is the X and B is my Y. So by definition of BCNF, the first three functional dependency which is dependent on AB, and A as AB is a super key, so these three satisfying the condition of BCNF. Now that is not enough, we need to consider the other functional dependencies also. So E determines B. Here E is X, which is not a super key, right? As E is not a super key, so this functional dependency E determines B does not satisfy my condition of BCNF. Now we need to decompose the relation which is in 3NF to make it in BCNF. So what is causing the problem? E determines B. So let us take out this one first. So we are going to get a relation R1 dependent on E and B, or relation R1 on the attribute E and B, and the other relation R2 will be on A and B, which will determine C and D. So these two relation you can see that are satisfying the condition of BCNF, and there will be only one primary key in case of BCNF. So E will be my primary key here in R2, AB will be my primary key. So these are in BCNF. So now let us take an example where we are going to analyze in which functional dependency is the relation is in, and how we can decompose in BCNF. So R is a relation A, B, C, D, and E with the functional dependency FD determines the functional dependency AB determines C, B determines C determines DE. So here AB determines C and B determines C and C determines DE. That will give me AB determines DE. So my candidate key will be AB, prime attribute will be A and B, and the non-prime attribute will be C, D, and E. Now take the second functional dependency. B determines C. So a non-prime attribute C is not fully functionally dependent on the candidate key AB. So R is not in 2NF. So we need to decompose it. How we can decompose it? Take the candidate key into one relation. So we have created the relation R1 with A and B, and take the relation, take the functional dependency which is causing the problem. So B determines C, that will be in one relation, and as C determines D, so that will go into the second relation. So the second relation, and we can ensure that these two relations are in 2NF. Now let us consider and let us take, is it in 3NF or not? Obviously, R1 there is no functional dependency, so we need not to worry about it. Let us take R2. In R2, the non-prime attribute, there are in R2, the candidate key is B and the non-prime attribute is C, D and E. Obviously, prime attribute will be B. Now, here you can see that considering the functional dependency, the non-prime attribute D and E is transitively dependent on the candidate key B, right? Because B determines C and C determines DE. So DE is the non-prime attribute which are transitively dependent on the candidate key B. So R2 is not in
BCNF.
so we need to decompose R2 into its
BCNF.
form. How we can decompose it? Obviously R1 will be there. Then R2 is decomposed in R21 where we take the candidate key and the attribute, non-prime attribute which is directly dependent on the candidate key. So we get B and C. Now take the functional dependency which is causing the problem, that is C determines D, and we put that into another relation R22. Here C will be my candidate key, here B will be my candidate key. Now let us take that it is in BCNF or not. R1 will not cause me any problem. B determines C, so B is a super key, so R21 is a candidate is in BCNF. Similarly, on R22 C determines DE and C is a super key, so R22 is also in BCNF. That is how we are going to check the normal form of a relation, of a given relation, and we are going to decompose the relation up to BCNF. Now, so that's it for today's video. In our next video, we are going to discuss about the dependency preservation and the lossless decomposition. So till then, stay safe. See you in the next video. Thank you.